So this video is about question 5 from the 2023 higher tier exam paper for Double Award Physics. And it's starting to get a little bit trickier now. We're into the end stages of the exam paper, so there's a little bit more demand on these. It starts off, this is actually weirdly out of the features of waves topic, and there is this little bit about satellites that exist within features of waves, which doesn't seem to fit, but when you think about the way they ask the rest of the question, it suddenly starts to make sense. So they give us some information. They give us a diagram here showing a geosynchronous orbiting satellite. Okay, so as you can see that it's orbiting the Earth. You can see that we've got something to do with the spin here. So here is my geosynchronous orbiting satellite. And then it says, state one way in which a geostationary orbit is different from the one above. So I'll do a separate video explaining the difference between the different types of satellite in more detail. But in terms of an exam answer, they're looking for one of two things. Well, either you could say that the geostationary orbits above one fixed point on the Earth's surface. That's absolutely acceptable as a definition for a geostationary. Or you could say that the geostationary orbits above the equator. So they're directly above the equator. Orbits above the, what am I doing? The equator. Okay, there's some AO1 knowledge. I'm sorry, but if you haven't learnt that, you are not going to be able to get that one. Then we've got a diagram. This is actually very helpful. We need to pay some attention here. So we've got a ground station. The signal goes up to the satellite, it then comes down to the second ground station. Okay, so we'll switch over for the second half of this question. Don't forget this, all the way up, all the way back down again. Okay, use the equation. Time is distance divided by speed to calculate the time interval between the microwave signal being sent from the Earth to one of the satellites and it being received back again. Remember, all the way up, all the way back. So let's take a quick look, shall we? So time is equal to distance. So we've got this, there's my distance, 3, 6, 0, 0, 0, get them all in. Okay, divided by, interestingly, they're giving us the speed of light in standard form. Okay, so we're gonna have to deal with that problem in a minute. And that is gonna be, so I'll show you on the calculator how you put those numbers in. So that's 3, 6, and just obviously hit the 0 button as often as you need to. Have I got the right number in there? Yes, I have. Divided by 3, and then this is the funky button that you need. This one here, so it's 3 times 10 to the, so if I press that button for you, there you go, 3 times 10 to the 8 equals 0.12. So we'll write that in here, 0.12. Now, if you remember, that distance there is only half of the journey. So we need to times that by 2, and that will give me 0.24. Okay, just a quick reminder that there's that special the special standard form button down here at the bottom that will help you put those numbers in your calculator. Okay, so microwaves travel at the speed of light and have a range of 1. Use an equation from page 2 to calculate the maximum frequency. So we are going to be using V equals frequency times wavelength, V equals f lambda. The speed of light we already have, that's 3 times 10 to the 8 from above. The frequency, we don't know, so I'm going to leave that as frequency. The maximum frequency will occur at the smallest wavelength. Okay, do a quick bit of rearranging. It's times on this side, so it's going to be divided if we move it over to the other side. So that's going to be 3 times 10 to the 8 divided by 0.002. That's going to equal my frequency. Calculator again. Here you go, I'll show you again how to do it. So get the whole calculator on this time. 3 times 10 to the 8. You see it appearing in the calculator window at the top. Divide by 0.002 equals 1.5 times 10 to the 11. Okay, we're going to leave it exactly like that. Physics markers understand standard form, so you can give it straight back to them like that. Okay, name one type of electromagnetic radiation which has a frequency smaller than those of microwaves. Hang on, so we're looking for we need to dig into our memory banks and remember the electromagnetic spectrum, and the lowest frequency, or the smallest frequencies, are the radio waves. And as microwaves is the next one up, the only answer we can have is radio waves. Okay, I hope that's been really useful for you. Remember, check out that video on the different types of satellites, and find some more videos, do a little bit more revision, and be really successful. Thank you very much. Bye now.